Hi everyone, in this tutorial I'm going to be going through how to save and load aggregations so you can share with your group members, and also how to use the catalog component within WASP to create proportions within aggregations. So I'm going to be using the 006 files for this tutorial within the student package. So I'm going to start with saving and loading aggregations, and it's quite a relatively easy way to do it. All we need is two components within the WASP library. So if we navigate to WASP, we are going to need, under aggregation, we're going to need the WASP load from file and then the WASP save aggregation to file. So we're going to start with how to save it first. So we're going to need the WASP save aggregation file. We're going to need a file path container just so we can create a directory. We're going to need a name for our aggregation and then a button to save our aggregation. I should also note I've created just a save and load aggregation Grasshopper file here, and if you open that, it basically looks like this, where you've just got the these two components set up for you that you can just copy and paste straight into your files straight away. I might actually just make sure this is up to date. So this, and this. I'm just going to delete this. Great. So once we have all that set up, all we need to do is we need to set a file path and a name. So I'm going to call this aggregation study 1, and I'm going to set a file path where I want to save the aggregation. So I'm going to right click on this file path container, go select a directory, and then it's going to ask me to find the folder that I want to save. I've created a folder called saved aggregations on my desktop. It can be anywhere, obviously, so I'm just going to save this here. And I'm going to call this save aggregation study 2. So now what I can do is I can go back and I can basically, go about what I would normally do in terms of aggregating, etc. And so we can then go and see the part geometry. Here, and once I get a interesting kind of aggregation that I'm happy with, then we can go ahead and save it. So saving the aggregation is good for kind of two things. Mainly if you're trying to share the aggregation with your group members, and it's a good way to make sure that you're starting from the same aggregation once you kind of have more developed projects. And then the other way is also it's good just to save these the aggregations that you find more successful, so then you can always add to them later if you need to. So once we're happy, we can just go ahead and click this button and click save. And if we navigate then to that folder that we've saved, you'll see that basically this file comes up and it clicks study 1, study 2. So we're gonna load this basically aggregation back into our Grasshopper files. To do that, we need the load aggregation from file components. I'm just going to update these. And so it needs basically two things. It needs to know where the file is, and it needs to know the parts that we've been using. So in terms of a workflow, if you were to share with your group members, you need to share a couple of things. You need to share the Rhino file with the parts that you're using. the Grasshopper file with all this set up, and then obviously also the saved aggregation file as well. So we're going to plug in first our part. So our parts being from here. So I'm using 2 parts, and then we're going to just clear this now, and we're going to plug in another file path container into file. And so this time we're going to right click on the file path, and we're going to go, instead of select a directory, we're going to go select one existing file, and it's going to open up this window, and we're going to go navigate to the folder that we've allocated the files, and we're going to click Aggregation Study 2. So now, just as we, when we're doing kind of a global constraint where it needs to know where the previous aggregation parts are, it's the same principle here. So we just connect our part out into previous. And so you can see instantly it's added to that aggregation. So now what we can do is we can then take this part out. We can plug it into this list length component here, into the input list. And what that's going to do is it's going to split the list basically. We're going to basically show us the original parts and then the new parts. So what I can do as well is I can start re-aggregating. Maybe let's do say 340 parts and press reset. And so now this top part here, if I hide this part here is just going to show us the whole aggregation. But we can see in list A, it's that original aggregation that we've saved and loaded. And then list B is going to be our new aggregation. So I can, if I turn these on, I can see now in brown, the old kind of aggregation that I'm starting with, and then the new aggregation that I'm aggregating over the top on. So you can see if I start to change this, even if I start it from 0, you can see that's the original, and that's the new way. So that's a really good way to work collaboratively within your groups. And then the same things applies if you're wanting to see which parts you're using, and then also see each individual glazing and detail that we've attributed. So all the information within the aggregation is all stored in that file for when you're loading it back, which is great. So that's how you save and load an aggregation. It's quite simple. The next thing I'll show you is the part catalog component. So this part catalog component, really, it allows you to define a fixed number of each type of part. But it also allows you to define proportions of parts. So you can have, 40% one part, 60% another part. One thing to note is it is based on probability, so it's not going to give you a completely kind of accurate all the time distribution, because it's still relational to your component connections, the components, the rules. So that's just something to bear in mind. So this needs a couple of inputs. So we need our parts. So this is coming from the result of the tree that we're merging our 2 parts. We need our values. So in order to do that, what we do is, because we've got 2 parts, we need 2 values. So we just get a merge component where we just merge, and we can just input a number slider with our 2 values. So then the last 2 are basically if the catalog is limited to a given number of parts is true. So that means it's basically we want 50 parts and 13 parts of each component. or if it's false, then we want to use these as proportional values. So we want 50%, or say 30%, and then 70%, or etc. And it's going to try to, probability wise, it's going to try to fit these. It might not always do that. And then we have an adaptive input where basically it's going to change its internal probabilities according to the aggregation state. So it's going to be try to be adaptive when you're using that probability proportions. So generally, this will only work if you're using the proportional number when this is false. So this then gets put into the cat sign, and then if we go in here, then what we can do is we can see we've roughly got three. Let's see, and I'm going to just take out this part out just for now. We've roughly got, so we've got 135 parts and 55 parts. So it's probably still not quite under those proportions. So maybe let's just bump this up a bit. Let's see. Now it's starting to be a bit more. Sorry, yep. Let's go 70 and 30. So 475 and 53. So there we go. So it's sort of trying to kind of get to that point. So I mean, this is something that's kind of, you don't have to use, but you can definitely play around with in terms of getting, if you wanted to get more of a part than another, then you can define those certain rule types within the part. So you can see I'm getting still quite a lot of those blue components comparatively to the orange components. And if I click this now, then it's going to throw an error because it's, see how we've only got 74 and 54. So let's say we want 60 and 40, and then we'll do 100 parts. Then we should get here 60 parts and roughly 23 of those orange parts. And so the reason why you'll see a discrepancy in the numbers is, like I was saying, is because you're still limited by the rule set that you're applying and the connection logic. So at some point there'll be a point at which you can't aggregate it anymore because there's the rules that you're applying are limiting the aggregation. So that's just something to bear in mind. So if this does go orange, it doesn't mean it's incorrect. It just means that generally it means that your rules, you either don't have enough rules, basically that it's kind of capping out at a certain amount of aggregation, or you need to adjust this kind of number of components that you're aggregating. So that's how you do proportions and load and save aggregations. I will see you in the next tutorial.